Hey, sixth graders, this is Mrs. Zimmerman here, and I've got the last lesson of chapter 6. Today we are doing equations with two variables. So normally we just have one, right? It could be any letter, but we only have one in our equation. Today we're going to switch it up and we're going to add two variables. So I'm going to head to the front and we're just going to go ahead and get started. So do you remember ordered pairs? Ooh, this right here, right? We used those when we were graphing. For example, the ordered pair is always x comes first and then y. This is the x-axis, this is the y-axis, and then if I had an ordered pair like this one right here, 3, 5, I could graph that point, right? My graph would need to have numbers on it. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. 0 is always right here. Okay, now in order to graph this, the first number is 3. That's the x, which means that will go on the x-axis right here. We're going to be in that column. And then my second number is 5. So I could go up 5 on my y and be right here, right? And then if I join those 2 points to where they meet, I would put my dot right there at 3, 5. Hopefully this is ringing a bell because we can use them to solve equations. You can take an ordered pair, solve an equation. Here's what I'm talking about. Okay, let's take a look at the first one. The directions say to tell whether the ordered pair is a solution of the equation. So, number 1 says y equals 2x, and my ordered pair is 3, 6. So here's what we're going to do. We're going to take the ordered pair, this right here, right? Remember, it's always x first, then y. So I'm going to rewrite my equation and put 3 and 6 in. This is the x, that's the y. So I'm going to rewrite my equation. Y equals 6. So I'm going to put a 6 where the y is, equals 2. And then if you look right here, x is 3. So I'm going to do 2 times 3. Okay, now 2 numbers right next to each other tell us to multiply. So what is 2 times 3? It's 6. And bring down the rest of the equation. And then does 6 equal 6? Are both sides of my equation true? Yes. So you would write yes. Okay, when you're showing your work on an assignment or a test or something, you would need to show me all of this substitution work, and then you could write yes or no. And we can use them to tell if these equations are true. So let's try a few more. Okay, we have another one. Y equals 4x minus 3. So here's my ordered pair, 4, 12. X equals 4 and y equals 12. So I'm going to come over to my equation and copy this down. Okay, y equals 12. So I'm going to put 12 where the y is, equals 4 times x equals 4. So we're going to do 4 times 4 minus 3. And I put the 4 in parentheses just so we know that we substituted it. And if I put the 2 4s right next to each other, it would look like 44, right? You could do like 4 times 4 minus 3 like this. It means the same thing. I just kind of like parentheses, but you do what you want. So now here we are. We need to see if this side of the equation is going to equal 12. So let's solve it. Order of operations. What is 4 times 4? We do multiplication first. So 4 times 4 is 16. Bring down the equals 12. Okay, now I have 16 minus 3. 16 minus 3 is 13. So now I have 13 equals 12. Is that true? Does 12 equal 13? No, that is not true. So 412 is not a solution to this equation. Here's my next one. Move it down a little. Okay, we have y equals 7x. All right, here we go. My ordered pair is right here. X equals 2, y equals 21. So we're going to come over to our equation. Y equals 7x. Y is 21, so I'm going to put 21 here, equals 7 times x is 2, so we're going to put that there. Okay, now we need to see, does this side of the equation equal 21? What is 7 times 2? 14. So I have 14, bring down my equals 21. Does 21 equal 14? No, it does not. So we're going to leave it just like that and write no. Okay, now let's just try one more just to make sure we get the hang of it. If it will go away. Let's see which one we want to do here. I'm trying to see if I have one with a fraction in it. I guess not. Okay, we'll just go back up to the top one. Here we go. Y equals 5x plus 1. All right, my ordered pair is 3, 16. So my x is 3, my y is 16. And I'm going to come over to my equation. Y equals 16. So we're going to put a 16 here. Equals 5, x is 3, plus 1. So, does this side of the equation equal 16? Let's find out. 15 times 3, or I just said the answer. 5 times 3 is 15. Bring down the rest of it. Now I'm going to do the addition. 15 plus 1 is 16 equals 16. Is this true? Yes. So if you think about the equations we just did, right, we had like y equals 2x plus 1 or something like this. Okay, there are two variables, a y and an x. Each of these variables has a name. One of them is going to be independent, like this, and the other is going to be dependent. You may remember these terms or heard of these terms in science, because a lot of science experiments you have to identify what's the independent versus the dependent variable. And the two variables in our equation are x and y. So one of them is independent, one of them is dependent. And how do you figure out which one? Well, you can only figure this out if you have a story problem to go with it. Let's look at this here, okay? The equation t equals 12p plus 12 presents the total cost in dollars of a meal with a tip for percent, okay? Now, there's a lot to unpack here, okay? First off, here's the equation, okay? And that's the equation we're dealing with. And we're talking about how much does a meal cost if we leave a tip. Okay, so like you tip your waitress at the restaurant, that kind of thing. Now, my two variables, one of them is independent and one of them is dependent. My first variable is t, which is the cost of the money, and the second variable is p, how much tip I leave. Okay, and you have to ask yourself, what depends on the other? Does how much I tip depend on, does my total depend on how much I tip, or does how much I tip depend on the total? Well, think that through, and your total cost is going to be dependent on whether or not you leave a big or a small tip. So the dependent variable in this case is going to be the cost. It's going to be t, the total cost. which means the other variable p for the percent is going to be independent. Now, I'm going to give you a little tip here, okay? Whenever you see an equation, the number or variable that is out here by itself, in this case it's the t, is always going to be dependent because it depends on whatever number you put here. And the number that's in the equation part is always going to be independent. Okay, so you can ask yourself these questions, what depends on the other, but ultimately we're talking about this, the t, the one that's all by itself is dependent and the other one is independent. Okay, so let's look at this one here. It says the equation A equals 25W represents the area of a rectangular dance floor with the width of W feet. The very first thing you always want to do is identify the equation. A equals 25W. Okay, that's where we're going to start. My variables are W and A. Now, I told you last time you can think about this, right? Does the area, so the space this takes up, depend on the size of the dance floor, or does the size of the dance floor depend on the area of the whole dance floor? And you could go round and round thinking about that, but if you remember, I told you this variable out here all by itself is always the dependent variable. So we know the dependent variable is going to be A, area, which means what's left, the one over here that's part of the equation, are independent, which is going to be the width, okay? Hopefully I didn't confuse you too much, but just looking at the variables and where they are will be the biggest thing to help you here, okay? Okay. Now, the next part of this lesson is graphing, okay? So you remember how we graphed that point at the beginning, right? We went over 3 and up 5 and we graphed a point. Well, we can do the exact same thing with equations. Okay, let me tell you what I'm talking about. Okay, for example, it says to graph the equation y equals 4x. Okay, I have my graph off to the side, and you're like, yo, what? How do I graph an equation? Okay, step 1, you're going to make a table. So we're going to start with our table over here. We have x and y. And if you remember back from when we did graphing earlier in the year, in order to graph a line, you need to have 3 points. Okay, and now I'm telling you, every single table that you make, you're going to put 0, 1, and 2. Those are going to be your 3 points. Okay, then we are going to figure out what does y equal. So if I have y equals 4x, right? And over here in my table, I'm saying that y is going to be 0. So let's put a 0 there. Y equals 4 times 0. What is 4 times 0? It's 0. So we're going to put a 0 here. Now let's do the 1. If y equals 4 times 1, what does it equal? 4 times 1 is 4. So then we're going to put a 4 here. And then my last one, what if we put a 2 where the x is? 4 times 2 is 8. So what does y equal? 8. Now that your table's done, you always have to have 3 pairs. Okay, now these 3 are all just ordered pairs. So we are going to write them as an ordered pair. And guess what? We can graph these lines now. This is very easy, right? We have 3 ordered pairs. So we're going to come over to our graph. We're going to label it. We're going to start with 0, 1, 2, 3. And so these are my x values, these are my y values, right? My y's go all the way to 8. So I'm going to count up to 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. Now, my first dot is 0, 0. So that's going to be just right there. My second dot is x is 1, 4. So my x is 1 right here, and then I'm going to go over 4, up 4. 1, 2, 3, 4. So I'm going to be right here. And then my next one is 2, 8, which is going to be right here. Once you have 3 lines, then you can connect them. See how we did that? Okay, so it's really just step 1 is to make a table. Okay, step 2 is to do the math, figure out your y values, and then step 3 is to graph. Step 1, make a table. Step 2, fill it out. And step 3, graph them. So let's look at that in another example. Y equals 2x plus 1. Okay, remember, step 1, to make a table. So I'm going to make my table. We always use what numbers? 0, 1, and 2. Now I need to fill my table out. So here we go. My equation is y equals 2x plus 1. So let's start with 0. Y equals 2 times 0 plus 1. We have to follow order of operations, so we multiply before we add. 2 times 0 is 0 plus 1. 0 plus 1 is 1. So we're going to go with 1. Okay, now my next one is y equals 2 times 1 plus 1. Multiply first. 2 times 1 is 2 plus 1. 2 plus 1 is 3. So we're going to go 3. Now, my next one, x is going to be 2 plus 1. 2 times 2 is 4. 4 plus 1 is 5. So I'm going to put 5 over here. Okay, so this was step 2. I just filled out my table, and now I'm going to write my ordered pairs. 0, 1, 1, 3, and 2, 5. Then step 3 is to graph. So your numbers on the bottom are very easy, right? Your x is always going to be 1, 2, 3. My y's, if you see over here, my y's go up to 5. So I'm going to count to 5. 1, 2, 3, 4, 5. Now, if your numbers in the y column were bigger, you could, count by 5s on each line. You could do like 5, 10, 50, you could count by 20s, you could count by 100, you could do whatever you wanted, okay? But here we are. So my ordered pairs, the first one is 0, 1. So I'm going to start at 0 and go up 1. So my first dot's going to be right here. Then I'm going to go over 1, up 3. And then I'm going to go over 2, up 5. Here I am, 3 dots. Let's connect them, add an arrow because it's a line, and you're good to go. All right, let's try one more. 4x plus 1. Okay, step 1, make a table. X, Y. 0, 1, 2. Okay. Step 2, let's fill it out. So my equation is y equals 4x plus 1. So I'm going to start with 0, right? Because that's my first x value. So I'm going to do y equals 4 times 0 plus 1. 4 times 0 is 4, plus 1 is 5. So here we go, we got a 5. Next one, we have y equals 4 times 1 plus 1. Well, oh, I just messed up. Oh my goodness. Anyone else catch that? 4 times 0 isn't 4. 4 times 0 is 0. Plus 1 is 1. So that's going to be a 1 right there. Whew, good thing I checked. Okay, here we go. Now we're going to do 4 times 1, which will be 4 plus 1, which is 5. Next one, y equals 4 times 2 plus 1. 4 times 2 is 8, plus 1 is 9. So I got my table filled out. Let's look at my ordered pairs. Okay, we're going to have 0, 1, 1, 5, and 2, 9. Okay, we're going to come to our graph, and the next thing we're going to do is graph them. So bottom one is easy, right? 1, 2, 3. Now my y column is 1, 5, 9. So what could I do? I think I could count by odds, right? I could do 1, 3, 5, 7, 9, 11. As long as you keep the spacing equal, you can number it however you want. So we're going to start with over 0 up 1. Then we're going to go over 1 up 5. And then we're going to go over 2 up 9. Now that we're here, we can graph. Add the arrow, and you're good to go. Okay? So the next thing, this is it. Okay, I know we covered a lot in this section. There was a lot going on. So let's just do a recap real quick so we're all on the same page. Okay? The first thing we did was we took an x and a y and we put them into the equation and we said yes or no. If we put this here, does it make the equation equal? The second thing we did was identified independent and dependent variables. The third thing we did was graphed those equations, which is what we just did. So if you need to review any 3 of those, you just go back to that point in the video and you can get a refresh on what those mean. Okay, hopefully you got this, a good lesson, and you'll be set to go. I'll see you next time.